Hello NIC aspirants, today we are going to discuss a very important topic, that is heap sort. Fine, heap sort. We will cover this topic in two parts. In first part we will just try to cover the basics of heap. So if we talk about heap, before moving on the actual topic of heap, we have to consider what do you mean by binary tree. What do you mean by binary tree? A tree is a binary tree in which each and every node, keep in mind, each node have at most two child. Fine, at most two child. What is binary tree? A tree in which each and every node has at most two child. If we talk about some examples like A, B, C, is it a binary tree? Yes, because this node has two child, this node has zero child, this node has zero child. So each and every node has at most two child. So if we talk about A, B, C, D, is it a binary tree? Yes, this node has one child, and zero child. So what is binary tree? A tree in which each and every node has at most two child. Fine. Now, next topic is what is almost complete binary tree. What is almost complete binary tree? If we talk about almost complete binary tree, first of all it should be a binary tree. First of all it should be a binary tree. What do you mean by binary tree? Each and every node has at most two child. Next property. First fill the left child, then only we have to move right child. Okay, so the second condition, the most important condition, is first we have to fill the left child, then only we have to move to the right child. Okay, we will take some example. Next, third is, and one more condition is again very important condition, that is first fill the one level complete, then only move to next level. Getting my point? So we have three conditions for definition almost complete binary tree. First of all, it will be a binary tree, then first fill the left child, then only move to right child, and after completely fill the one level, then we can insert to the next level. Okay, now if we talk about some examples related to almost complete binary tree, can you tell me is it a binary tree? Yes, it is a first of all binary tree. So it is a almost complete binary tree? Yes, it is almost complete binary tree. Why? First fill the left child, then only we move on the next level. One more example is, so can you tell me, is it a binary tree? Yes, because each and every node has at most two child. So can you tell me, is it a almost complete binary tree? No. Why? If we talk about the right child has right of the 1, right child of 1 is 2, but before filling the left child we move on the right child. Fine, so it violates the second property. Fine, so it is not almost complete binary tree. Next, it is a binary tree? Yes, but it is not almost complete binary tree. Why? Because without completely fill one level we move on the next level. That is not possible in almost complete binary tree. Getting my point? So in this way we can find out that what is almost complete binary tree. Now what is heap? If we talk about heap, Heap is a almost complete binary tree. Heap is almost complete binary tree with some conditions. We have two types of heap. Two types of heap. First one is min heap and the second one is max heap. Getting my point? So first one is min heap, second is max heap. But first always keep in mind that heap is always a almost complete binary tree. If it is not a almost complete binary tree, then it will be not a heap. So we have two different types of heap, that is one is min heap and second is max heap. If we go with some examples of min heap, in min heap, keep in mind, in min heap, first of all it is a heap, it means it is a almost complete binary tree. But what is the main points or the main property of min heap? In min heap, root or the parent element is always less than equal to, keep in mind, parent element is always less than equal to its child. Fine. So 10 is always less than equal to its child. Fine. 10 is always less than equal to its child. Fine. Now 20 is always less than equal to its child. Yes, 20 is always less than equal to its child. So can you tell me, is it a almost complete binary tree? Yes. Is it a min heap? Yes. Because each parent is less than equal to its child. Each parent is less than equal to its child. Getting my point? So if we talk about the example of max heap, again the parent is always greater than or equal to its child. Fine. So if we talk about the example of max heap, we can say 100, 90, 80, 70, 60, 50 and 40. Getting my point? So see, parent is always greater than its child. Parent is always greater than its child. Parent is always greater than its child. Getting my point? So till now we will cover what is binary tree, what is almost complete binary tree. Now what is heap and what is min heap and max heap. Getting my point? Fine. If now the first operation we can perform on a heap is insertion. How to insert an element in a heap? Insert an element in a heap. Suppose I have a heap, I have a min heap or maybe max heap. Fine. So I am taking the example of min heap. Suppose 10, 20, 30, 40, 50, 60 and 70. As the input is min heap, so I want to insert one element. Suppose I want to insert an element that is 100. I want to insert an element that is 100. Now tell me where I can insert or from where I can start my procedure. So as we already know, a heap, in a heap always we start with the, like if there is an empty space in one level, then first fill the one level, then only move to next level. Because this level is completely filled, so we will start with next level, left child. Okay. So we will insert 100. Now after inserting, what we have to do? After inserting the element 100, now I have to compare. Can you tell me 40 is less than 100 or not? Yes. So only comparisons required. But in this case no swap required. Fine. So it follows the property of min heap. So can you tell me how much time it requires? It required only constant amount of time, only insertion amount of time, the amount which will take to insert an element, or one single comparison time. Fine. So in best case, I can say in best case the time required to insert an element in either min heap or max heap is omega of constant. Getting my point? So move on the next worst case performance. So suppose again the same heap I have 10, 20, 30, 40, 50, 60 and 70. This time I want to insert one element that is 5. I want to insert element 5. Now tell me again, I have to insert element 5 here. Getting my point? No, first of all we have to perform some comparison. Can you tell me, out of 5 and 40, which one is smaller? 5. So do one swap. So 5 will be here, 40 will be here. Again I have to perform some comparison. 5 and 20, which is smaller? 5. So 5 will be here and 20 will be here. Next again 5 and 10, 5 will be here and 10 will be here. Fine. So can I say the final heap is 5. Now 10 and 30, now 20 and 50, and this side 60 and 70, and the last is 40. Fine. So now tell me how many comparisons we have performed and how many swaps we have performed. If we talk about the number of comparisons, can I say the comparison goes in this side? So it is log n base 2 comparison. Getting my point? Why base 2? Because it's a binary tree. Fine. So total number of comparison is log n base 2. Why log n? The height of the tree is log n. So total number of swap required in worst case, again log n. So if we talk about the total time, log n plus log n, 2 log n, asymptotically it is log n. Getting my point? So if we talk about the best case to insert an element in either main heap or max heap, constant time. If we talk about the worst case, it will be log n. Getting my point? So now if we move on the next operation, that is delete. Delete. If you want to delete an element from a heap, fine. Suppose I have a heap that is 10, 20, 30, 40, 50, 60 and 70. Always keep in mind that in a heap we can always delete the root element. Fine. In heap, only possible case to delete the element is the root element. So delete 10. My task is to delete the 10 and again make my tree in a heap. So my task is to delete, perform one time delete operation, that is delete 10. So now keep in mind, if you want to delete 10, okay, 10 will be deleted. Now if it is a min heap, which element we can replace? Suppose we are trying to compare the siblings and 20 is the minimum one, so we can go with the 20. So now root is my 20, here we have 30, here we have 60 and here we have 70. Fine. But again, as 20 moves to upwards, this space will be blank. Now again 40 and 50, which one is minimum? 40. If we put 40 here and 50 here, but what's the problem in this case? What's the problem in this approach? The left child of 40 is empty and now it is not a almost complete binary tree. That's why it is not a heap. So the problem is this approach is wrong. Keep in mind, this approach is wrong. Fine. So how to delete an element? If we want to delete an element, suppose we have a heap 40, 50, now 60 and 70. If you want to delete 10, so what you have to do? You have to replace 70, or you will take the last element and just keep at the root. Okay. So now what is my tree? Now my tree is 70, 20, 30, 40, 50 and 60. As I want to convert this given tree after deletion into a min heap, so again apply the same procedure which is called heapify. So compare 20 and 30, which one is smaller? 20. So 20 will be here, 70 is here. Now again 40 and 50, which one is smaller? 40. So 40 will be here and 70 is here. So my resultant tree is 20, 40, 30, 70, 50 and 60. So can you tell me how much time it will take? First of all, we have to take the last element and put at index 0 or the root element. Then we will perform some comparison and some swap. So how many comparisons? Again log n comparison plus again in the worst case log n swap. Keep in mind. So what is the total time complexity? That is order of log n. Fine. So we will see two operations, that is insert and delete. So if we move on the conclusion part, so the conclusion part is to insert an element in min heap or max heap, best case time complexity constant, worst case time complexity log n. But if in case of delete, time will be log n only. Getting my point? So what type of problem you can face in NIC exam? So maybe you will find that given a input which is a heap, and after performing 3 deletions, can you tell me the level by order element? Okay, so the sequence of elements, if we traverse the given heap after performing that some number of iterations or some number of deletions, what is the element or what is the sequence of element as level by level order traversing? Fine. Or you may face some problem related to the time complexity. To insert an element, in worst case how much time it will take? To delete an element, how much time it will take? So these are the basic problem. The easy one problem, you must go through some of the problems related to heap. Fine. In ISRO, DRDO or in GATE exam, we have many problems related to heap. Just go through that, and if you have any doubts, so please comment in the comment section box. Okay, or either you can reach to NIC YourPedia module. Thank you so much.